You walk out of the exam hall totally certain you nailed the physics. You memorized the equations, you understood the concepts, but then results day hits, and your grade is way lower than you expected. Why? Because there's a massive hidden gap between what you think your teachers want to see and what Cambridge examiners actually reward. In this explainer, we are jumping right in with zero fluff. We're going to decode the hidden patterns in the Cambridge 0625 physics practical data questions. We're going to expose exactly why you lose marks on topics like Hooke's law, spring constants, moments, and center of gravity, and replace your standard revision with the precise language the mark scheme is practically begging for.
So why do perfectly good Hooke's law answers score 0 marks? Let's dive right into this painful exam scenario. You know the physics, right? But you still lose marks on the practical data questions? It's kind of like a secret hidden in plain sight. Imagine you get a question asking you to describe how to determine the spring constant of a stretched spring. You confidently write down force equals spring constant times extension. You feel great. You move on. But that answer? It scores 0. Maybe 1 mark out of 4 if you're lucky. See, the examiner isn't testing if you memorize the equation. They are testing if you know how to actually get the data to put into that equation in a real-world laboratory setting.
And this brilliantly illustrates the ultimate practical mistake. It instantly puts your grade boundaries at risk. Just look at the difference here. On the left, that's what you write, just the raw math. But on the right, that is what the examiners are reading, a giant glaring void of missing practical details. They are desperately looking for you to mention checking for 0 errors on your ruler. They want to see you explicitly describe reading the scale at eye level to avoid parallax error. They are hunting for you to state that the extension is actually the new length minus the original unstretched length. If you just toss them the equation, you are literally throwing away the easiest marks on the paper.
Section 4. The examiner answer framework. Here is exactly how we fix this using a hidden pattern. See, ordinary revision fails because it focuses purely on textbook facts instead of exam application. To guarantee top marks, you've got to think like the person holding the red pen. So the crucial point here is memorizing this specific 4-part framework. It literally unlocks the mark scheme for any forces practical. Step 1, state the concept clearly. Step 2, provide evidence or data straight from the source or the table they give you in the question. Step 3, apply scientific reasoning to connect that data right back to the concept. And step 4, honestly the most important one, use precise examiner wording. Let's see exactly how this plays out in practice. We'll ground the very first step of our framework, the concept, with this incredibly strict Cambridge definition of Hooke's law. If a question asks you to evaluate whether a set of results obeys Hooke's law, you can't just say, oh, it goes up evenly. No way. You absolutely must establish the baseline. The extension of a spring is directly proportional to the applied force, provided the limit of proportionality is not exceeded. That final clause, completely non-negotiable if you want those top band marks. Section 7, Hooke's law graph skills, because knowing the definition is really only half the battle. Okay, I want you to look really closely at this data table and try to spot the painful learner mistakes. See the column headers? They just say force and length. There are no newtons, there are no millimeters. That is an instant mark lost right there. Now check out the actual data points. The length increases steadily, right? But wait, look at that 4th reading. It spikes way out of trend, and the student just left it sitting there. Guys, this is a classic exam trap. To hit the top band, examiners are hunting for these specific rapid-fire corrections in your data analysis. You've got to spot those missing units immediately. You must circle anomalies and explicitly state that they should be repeated or completely discarded. When you're calculating the gradient from a graph of this data, you have to draw a large triangle, one that covers more than half the line of best fit. And finally, you must state practical improvements, something like using a set square to ensure your ruler is perfectly vertical. In a moment, I'll show you the hidden center of gravity clue that shifts an answer completely from a B to an A. But first, you need the scale framework that makes that clue obvious. Because before we get to those really tricky explanations, we absolutely have to tackle the one calculation trap that ruins perfectly good physics knowledge. Section 11, the balancing ruler challenge. Let's escalate the stakes a bit by applying our framework to a much harder Cambridge-style example. I want you to pause and predict right now. Look at this calculation for a balancing ruler and try to spot the fatal flaw. The student has correctly identified that the clockwise moment equals the anti-clockwise moment. They've plugged in the forces, they've plugged in the distances, they did all the math, but the final answer on the line, it gets completely rejected by the mark scheme. So why? What exactly did they do wrong during the process? The answer is rounding too early. It's a massive trap that completely destroys the accuracy of your final spring constant or moment's value.
Here's what happens. When you calculate an intermediate step, like finding the exact distance from the pivot, and you round it to one significant figure before plugging it back into your main equation, your final answer drifts completely outside the acceptable range. Examiners see this all the time. You have to keep your full values in your calculator until the very final step, and only then do you round to match the lowest significant figures given in the question's data.
Section 14, correcting center of gravity. Okay, let's tackle that center of gravity clue I promised you earlier and look at some examiner-style corrections. When a ruler isn't uniform or when the pivot isn't exactly in the middle, students tend to panic. Just notice the contrast here between a vague, flawed student explanation and the precise terminology examiners actually demand. Saying the ruler is balanced in the middle might sound okay to a beginner, but it earns you absolutely nothing. The improved top-band answer uses our framework's final step, examiner wording. You need to write, the center of gravity is at the pivot point, so the resultant moment is 0. Boom. You've stated the concept, you've linked the physical location to the pivot, and you've concluded with the scientific reasoning that the resultant moment is 0. That right there is an absolutely bulletproof answer.
Section 16, the unresolved exam problem. You now have the secret playbook for data questions, but there is still one massive trap left. You have the perfect answer. But do you have the time? That is the ultimate unresolved problem here. Exam timing. Because knowing the precise examiner wording is absolutely useless if the clock runs out before you actually write it down. I see brilliant students drop a whole grade boundary, not because they didn't know the physics, but because they spent 8 minutes writing a massive paragraph for a 2-mark question. And that leaves them with 0 time for the really difficult 6-mark practical design question at the end of the paper. To solve this and get your hands on the timed answer writing system, you must do exactly what is written on this slide. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click the explainer on the screen right now to decode the examiner language and master your timing, because your top grade literally depends on it. We're going to take everything you just learned about the practical data framework and show you exactly how to execute it perfectly before that clock hits 0. Because think about it, if an unbalanced moment can topple a massive bridge in the real world, what is an unbalanced, poorly timed exam strategy going to do to your final grade? So, are you ready to stop thinking like a student and start writing like an examiner? Click over now, and let's keep building that perfect exam strategy.